During cardiopulmonary bypass, what is the main purpose of using a venous reservoir? A. To store blood until it is oxygenated. B. To collect venous blood from the patient and prevent air from entering the circuit. C. To warm the blood before it enters the oxygenator. D. To measure the patient's blood volume. Answer: B. To collect venous blood from the patient and prevent air from entering the circuit. Explanation: the venous reservoir collects deoxygenated blood from the patient and ensures that air does not enter the bypass circuit. It also helps maintain the desired blood volume and provides a buffer for the blood returning to the system. Why is it important to monitor the level of oxygen saturation in the blood during cardiopulmonary bypass? A. To prevent the blood from becoming too acidic. B. To ensure that the oxygenator is functioning properly and delivering adequate oxygen. C. To regulate the rate of blood flow through the circuit. D. To prevent excessive hemodilution from the priming solution. Answer: B. To ensure that the oxygenator is functioning properly and delivering adequate oxygen. Explanation: monitoring oxygen saturation is essential during cardiopulmonary bypass to ensure that the oxygenator is providing adequate oxygenation. Low oxygen saturation indicates a potential problem with the oxygenator or inadequate flow through the circuit. What is the primary function of the cardioplegia solution during cardiopulmonary bypass? A. To induce hypothermia in the patient. B. To prevent myocardial ischemia by arresting the heart. C. To regulate blood pressure during surgery. D. To oxygenate the blood during the procedure. Answer: B. To prevent myocardial ischemia by arresting the heart. Explanation: cardioplegia is a solution used to induce cardiac arrest during surgery. It typically contains high potassium concentrations to stop the heart's electrical activity and protect the myocardium from ischemic damage during open-heart surgery. During cardiopulmonary bypass, which of the following is the most important parameter to monitor to prevent damage to the organs due to inadequate perfusion? A. Blood pH. B. Oxygen saturation. C. Mean arterial pressure, MAP. D. Arterial blood gas, ABG, values. Answer: C. Mean arterial pressure, MAP. Explanation: mean arterial pressure, MAP, is the primary parameter used to assess the adequacy of organ perfusion. A MAP that is too low could indicate inadequate blood flow to vital organs, risking damage due to ischemia. Why is it important to continuously monitor the activated clotting time, ACT, during cardiopulmonary bypass? A. To ensure the heart remains in arrest. B. To monitor hemodilution caused by the bypass circuit. C. To assess the adequacy of anticoagulation and prevent clot formation. D. To ensure the proper function of the oxygenator. Answer: C. To assess the adequacy of anticoagulation and prevent clot formation. Explanation: the ACT is used to monitor the level of anticoagulation during CPB, ensuring that the blood does not clot within the bypass circuit. Adequate anticoagulation is essential to prevent clot formation, which could lead to embolism or circuit blockage. Which of the following is the primary advantage of using a centrifugal pump over a roller pump in cardiopulmonary bypass systems? A. It is more accurate in regulating flow rates. B. It generates less shear stress on blood. C. It is less prone to clot formation. D. It requires less power to operate. Answer: B. It generates less shear stress on blood. Explanation: a centrifugal pump generates less shear stress compared to a roller pump, which can be beneficial in minimizing the risk of blood cell damage during circulation. This reduces the risk of hemolysis and improves the overall safety of the procedure. Which of the following is the most common complication associated with the use of the oxygenator during cardiopulmonary bypass? A. Infection from bacterial contamination. B. Hyperthermia. C. Inadequate oxygenation and CO2 removal. D. Air embolism due to faulty equipment. Answer: C. Inadequate oxygenation and CO2 removal. Explanation: a malfunction of the oxygenator can lead to inadequate oxygenation of the blood and ineffective removal of carbon dioxide. This can result in hypoxemia and acidosis, which can affect organ function. Continuous monitoring of oxygen saturation and blood gases is necessary to ensure proper oxygenation. What is the function of the arterial line filter in a cardiopulmonary bypass circuit? A. To measure the patient's blood pressure. B. To oxygenate the blood before it is returned to the patient. C. To prevent embolism by trapping air and clots. D. To maintain the pressure in the arterial line. Answer: C. To prevent embolism by trapping air and clots. Explanation: the arterial filter is designed to remove any particulate matter or air bubbles from the blood before it is returned to the patient's arterial system. This is crucial to prevent embolism, which could lead to stroke or other serious complications. During cardiopulmonary bypass, what is the primary reason for monitoring the central venous pressure, CVP? A. To assess the function of the roller pump. B. To evaluate the effectiveness of the oxygenator. C. To monitor blood volume and venous return. D. To detect the presence of air embolism. Answer: C. To monitor blood volume and venous return. Explanation: central venous pressure, CVP, reflects the pressure in the venous system and is an important indicator of blood volume and venous return during cardiopulmonary bypass. Monitoring CVP helps manage fluid balance and ensure that venous return is adequate for proper perfusion. Which of the following would most likely be used to assess the oxygenator's performance during cardiopulmonary bypass? A. Blood gas analysis. B. Central venous pressure, CVP. C. Heart rate monitoring. D. Intra-aortic balloon pump, IABP, pressure. Answer: A. Blood gas analysis. Explanation: blood gas analysis is used to monitor the oxygenation and carbon dioxide removal performance of the oxygenator. By analyzing the partial pressures of oxygen, PaO2, carbon dioxide, PaCO2, and pH, clinicians can assess whether the oxygenator is performing adequately.